Good morning, good evening, or good afternoon, whenever it is that you're watching our videos. Today, we are going to be covering section 2.12, compounds is the topic. And fifth period, again, will be my assistant class. And the first topic or the introduction talks about what you need in order to build a house. Who's going to read for me? Who's going to help me here?
Can I read, miss?
Of course, ma'am. Go ahead.
Houses take on a variety of shapes. Some are large mansions, while others are simpler dwellings, no matter what the house together
Looks like.
what the house looks like. There will be certain common compounds: wood, brick, plaster, nails, plumbing, wiring, etc. These components go together in numerous ways to make up the unique final product.
Thank you. That's enough. Thank you. All right, perfect. So, Alexia, thank you for helping me out. As you can tell, anytime that somebody is building a house, and we've passed by a lot of places, a lot of construction sites where you see all the materials that are needed, right? You will need definitely a lot of wood. You're definitely going to need some bricks or metal siding, whatever it is. It depends on what the type of building, right? You will need bricks. You're going to need plaster. You're going to need plumbing supplies. You're going to need wiring supplies and a whole bunch of things in between, right? Well, these are the bits of materials that you need to make that big old house or a small house, whatever it is. Elements work the same way for compounds, okay? There are certain elements that will come together, bond, and form a compound. For example, hydrogen. Hydrogen gas and oxygen gas, well, they have different elements on their own, right? Oxygen, usually a gas, hydrogen, also usually a gas. And once we chemically combine these two elements, they form something known as water. Water is a compound. How do I know that it's a compound? Why? Well, it has two elements or more. If you have a substance that's made up of more than one element, that's a compound. Whether it be water, whether it be carbon dioxide, whether it be acetate, acetone, whether it's hydrogen peroxide, and everything else in between. Okay? That is what we're going to be talking about today. So it says here, compounds in chemistry are composed of different types and numbers of atoms, but atoms are common building blocks for a wide variety of compounds, just like the brick, the wood, and the other materials are the common building blocks for many types of houses. Now, the definition that you need to know. A compound is a substance that contains two or more elements that are chemically combined, chemically bonded. Okay? And the number of each element will be specific to that compound. Okay? If I change the number of elements, I have changed the compound completely. All right? If I have H3O instead of H2O, that's completely different. Water is H2O, H3O is hydronium. Two different compounds. They'll have two different properties. Okay? An example that they give us, the elements carbon and hydrogen combine to form many different compounds. One of the simplest, most basic compound is called methane. Flatulence, right? Everybody has flatulence once in a while. So in order for you to have methane, you have to have 4 times more hydrogens than you need to have carbon. What do I mean by that? All that means is it's a fancy word for the formula CH4. There are 4 times as many hydrogens as there are carbons. Here you can see that there's only one carbon, right? There's no number at the bottom. That means there's only one. Hydrogen, there's a 4 behind it. That means that there's 4 of this element right here. That is methane. Methane is a pure substance because it always has the same composition. If I don't have 4 hydrogens, it's not methane. If I don't have 1 carbon, it's not methane. Got it? That's what we mean by fixed proportion. The numbers have to be specific. You know what I mean? Okay. And however, it's not an element because it can be broken down into simpler substances. So the example that we're talking about, methane, is a compound. Why? Because you see 2 capital letters. That means there's 2 elements. Can I break this guy down? Yeah, I can break it down, but I have to put it through a reaction. Okay, I can separate the carbon and the hydrogens back into individual elements. If you remember that the components of a mixture, right? If I have a mixture like oil and water, I can separate those by physical means. There's a way, whether it's by filtration, distillation, chromatography, evaporation, I can separate those 2 substances. Why? Because they're not chemically bonded. When it comes to compounds, you cannot do it unless you put it through a chemical reaction. Okay? Like they talk about table salt. Everybody knows what salt is, right? Salt has a formula of NaCl. This is salt. Okay? Table salt is a compound consisting of equal parts. Are they equal, these 2 elements that we have here? Are they equal? Do I have 1 sodium and 1 chlorine? Yes, I do. If I change the number, if I have 1 sodium and 3 chlorines, it's not salt anymore. Okay? Make sure you have that clear. Salt cannot be separated into elements by filtering, distillation, or any other physical means. I can't filter out salt from the chlorine. I can't filter chlorine from sodium by filtration or distillation. All I'm going to do is just change it the way it looks. Salt and other compounds can be decomposed into their elements by a chemical process. What is a chemical process? It's also known as a chemical reaction. Also, you say that substance has undergone a chemical change. Now, what's a chemical change? Well, chemical change is like when you burn paper. The chemical properties of paper have completely changed to ash. The properties that paper had is going to be way different than the ash that you have left behind. A chemical change is a change that produces matter with different composition. When you're talking about composition, you're talking about the properties that make up that piece of matter. Many compounds can be decomposed into their elements by heating it up. And an example that they talk about is sugar. Okay? They talk about sugar being heated. Okay, and I'm going to put it in the formula. I'm not going to, that's what I want to do. So if I have sugar, and I don't remember if this is the actual formula, but if I have sugar, I can separate carbon, but I'm not separating hydrogen and oxygen. As you can see, if I heat up sugar, I will get that carbon element back, but look, I make another compound, water. But if I want to separate water into its elements, hydrogen and oxygen, I have to do another chemical change. I need to pass some electrical current. So if I have water plus electricity, I'm going to get back the original elements. And there's actually a video that shows you how that's done. Okay? But this guy is different than this guy, which is different than this guy. And this guy right here, water, is different than these two right here. They will act different. They will look different. That's what we mean by chemical change. The properties of the substance has changed completely through a chemical reaction. In this case, the first one was just adding heat. The second one was just passing electricity through it, giving it enough energy to break those bonds. Okay? The properties of compounds are generally very different than the properties of elements from which the compound is formed. Sodium, and they give you another example. Sodium, there's a picture right here. Look at it. It's got a silver shine to it. It's a very soft metal. It's a soft metal that you can actually cut it with a butter knife. Okay? But look at a property. This is a property. It cannot be exposed to air and water. If you don't have it in a solution like it is here, look, it even tells you sodium is so reactive that it has to be stored in oil in order for you to have it in its elemental form. Chlorine. Have you guys ever you guys have been in a pool, right? So you know, you probably have felt the chlorine on your body. That's the liquid form. Look at it in a gas. It tells you that chlorine is a deadly gas. So that property goes away. Once you have added and reacted these two elements, you get this nice, this table salt that you see here. We sprinkle it on our food. It's not deadly anymore. Is sodium reactive still? No. Those two properties have gone away once they have bonded together. Okay? I hope you understand that. All right, let's watch this video.
What is a chemical compound? Let us learn what a chemical compound really is. Click on the titles listed here. Atoms, molecules, elements, and compounds. When two or more elements bond together chemically, they form a new substance with its own properties. This combination of elements is called a compound. Water is a compound made of hydrogen and oxygen. Carbon dioxide, which is what you release when you exhale, is a compound made of carbon and oxygen.
So, you have undergone a chemical change. All right, they're not talking about it, but you know it has happened because those elements don't just come together. You have to put it through a reaction. You have to add some energy, you have to add some heat. I don't know. Every reaction is different. Okay?
Most substances around you are compounds or mixtures of compounds. All compounds are made up of molecules. A molecule is the smallest part of the compound that has all the properties of that compound. For example, a molecule of water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Let's compare compounds and mixtures. Combining elements to form a compound is different from just mixing elements together. In a mixture of iron filings and sulfur, for example, each element holds on to its original properties. You can separate the mixture easily by dragging a magnet through it, attracting all the iron filings.
So right now, in this heterogeneous mixture or homogeneous, I don't know, we don't know if it's uniform or not, but you can tell that the iron still has a magnetic property, right? Even though it's mixed with the sulfur, it's not chemically bonded, so I can easily separate those components or those parts. Let's see what happens if we add heat.
But if you heat the mixture, a chemical reaction takes place that bonds the elements together. Not only does the new compound look different, but it also has no magnetic properties. Thus, compounds do not possess the properties of the elements which they are composed of.
So just because that iron was magnetic before you did the chemical change does not mean that afterwards it'll still be magnetic. Okay? And they proved it right now, right? They heated it up, they chemically combined those two substances, and they went ahead and they brought the magnet back. Will it still be magnetic? In this case, no. The magnetic property has gone away after this chemical change has occurred.
Separating the chemical compounds. Unlike mixtures, which are fairly easy to separate, the strong bonds in a compound can be broken only by chemical means. By using electricity, we can break the bonds holding the elements hydrogen and oxygen present in the compound water. When an electric current passes through two tubes full of water, it breaks the tight bonds between the hydrogen and oxygen atoms in each water molecule. Oxygen atoms bubble up to fill the blue balloon, while hydrogen atoms fill up the red balloon. There are 2 hydrogen atoms for every atom of oxygen in a water molecule H2O. Therefore, the red balloon fills up faster.
So here is a continuation of the example where we talked about the sugar breaking up into carbon and water after it's been heated. Well, now we're at that second part. This is where they're adding that electric current. This is an electrical circuit right here that you have. When this was lifted, that circuit was broken, no electricity was running. As soon as we lowered and connected the circuit, you have your anode, you have your cathode. The cathode is like having the positive end of a battery. The anode is the negative end of a battery. And as you can see, the anode is the one that produces the oxygen, and the cathode is the one who produces that hydrogen gas. And why is it different as far as the size? Well, anytime you have a reaction run for water breaking up into hydrogen and oxygen, you always end up with more hydrogen, or double as much hydrogen as you do oxygen. Okay? And I'm going to tell you why later. Right now, I don't want to confuse you.
Thus, when water is electrolyzed, oxygen gas is formed at the anode, while hydrogen gas is formed at the cathode. Energy changes take place when chemical compounds are broken down. Just a difference of one atom.
Look at this one, guys. This one is really interesting. It's the same elements. Look at that. I have iron, Fe. I got chlorine, Cl. They're both the same elements. But the only difference is I got 2 chlorines on the left and 3 chlorines on the right. Look at what the difference of just adding one more chlorine does to this substance. It has changed colors completely. Okay, that is the difference adding just one more chlorine.
The compounds displayed here may not look alike, but they are made of the same elements: iron, and chlorine. The only difference between them is one atom. Ferrous chloride, FeCl2, has one atom of chlorine lesser than ferric chloride, FeCl3. The proportions of the elements present in a compound must remain constant, or else the compound changes into something else.
All right. Thank you, sir. Okay, now here's an interesting video about how we get those beautiful colors in our fireworks display at the beach or at 4th of July at your house or whatever. Wherever you see fireworks, guys.
Fourth of July, a day for parades, barbecues, chemistry, well, at least these chemical reactions. But have you ever wondered why the Inca Gold shoots off yellow flaming balls while the Fiery Eye produces a red and blue ring? Chemist Bassam Shakashiri has the answer.
The bright lights are produced by heating metal salts that emit characteristic colors.
For example,
Yellow is usually produced by sodium chloride, ordinary table salt. Barium chloride gives you a nice green color. Copper gives us the beautiful blue color. Strontium chloride will give you a bright red color. Sometimes, we see purple colors. So what do you suppose the purple colors are due to? They're due to a mixture of what produces red and what produces blue.
to understand where this light comes from, let's take a specific compound. Okay, imagine this is sodium chloride. When it's heated,
The electrons go to a higher state called an excited state. And when they fall back to the ground state, they emit energy. If the energy happens to be in the visible region of the electromagnetic spectrum, then we see it.
as this. As for the chemical composition of these guys, you'll just have to wait until next year. Specific.
The electrons
All right, so let's talk about what we mean by that excited state. Okay, and I'm just going to go through it quickly. So, if this is your nucleus, right? This is your nucleus to your element, to your atom. Electrons will travel in orbits around it, just like we Earth travels around the sun. Electrons do the same thing, right? And our orbit, like Earth's, doesn't usually change. The only time that it's going to change is when you add energy. If you have enough energy, like you do in the firework, you're basically giving energy to these atoms. Now, chemistry, if you didn't know, is all about studying what electrons do because they're the ones who do the movements. So when that electron is orbiting and you add energy by an explosion like you see in the firework, that electron will jump from being in a small orbit to being in a big orbit, right? And eventually it's going to have to release that extra energy. And as it's doing it and it goes back to that original orbit, it's going to release the energy that it absorbed, and it's going to reflect that energy in the form of light. That's why you see it real bright at the beginning and then it starts to fade, because it's losing the energy that it absorbed. Isn't that neat?
Hey man, that's true, man. I never thought about it.
Yeah, that's why it fades, because it's losing the energy. As that electron goes back to the original orbit, it's losing that energy and it's going back. Okay, I'm excited. I'm going around and around and around in this big orbit, but I can't stay here because I don't have enough energy. So I'm back. And that's why you see light. And each metal gives off a different color. Okay, and it's the metals that do all the changing. I don't know if you noticed, but it was all of those metals were attached to chlorine.
Yeah, because someone's like, they're blue metal, the one they change color, like there.
Right. You get a different metal, that metal gives a different color. No, I didn't see it. Oh man, why didn't you tell me on Friday, girl? I would have looked up.
Es que mi mamá nos dijo y luego yo me salí, ¿verdad? Y estaba next to the moon.
Oh, wow. I didn't know that. You need to tell us these things, Alexia. All right. So that's just a little bit about fireworks and electrons and how cool they are. And we're going to talk a lot more about those electrons. All right. So let's close it up. Let's finish up. Let's do these questions so we can talk about Flipgrid and you guys can get that test grade so it can boost up your grades. And especially those who you've been having trouble turning in assignments, that Flipgrid grade is a test grade. Okay? And test grades, you got to remember, test grades are worth 35% of your grade. As long as you do the video, you're going to get an 80. But let's talk about that right now. Let's finish the questions. All right. Well, first off,